Let's talk about buffers. Buffers are something that helps resist change, and they do this by helping to control some variable. And here are some buffers that are relevant to a chemist. Um, there are temperature buffers, metal ion concentration buffers, and then H plus buffers, or pH buffers. Most of our discussion will be about pH buffers, but I will mention that temperature can also be buffered. If you live in a coastal area, you'll notice that the temperature does not change as drastically as somewhere inland. This is because water has a very high heat capacity, and it takes a lot of energy to change the temperature of it. And that water helps resist the temperature change and keep it a little bit more consistent. It's also possible to buffer a metal ion. In this case, we have a reaction between, say, calcium and a chelating ion called EDTA, or ethylene diamine tetraacetic acid. This is a way to control the calcium concentration. I'll just write right over here what that looks like. So, calcium ion plus EDTA ion, which is sometimes abbreviated as Y. And it's abbreviated even more than EDTA. So this is a way to control how much calcium is available or floating around in the solution. This is done with other ions as well, like lead or something else, and often in very sensitive applications where we must have very small amounts of free metal ions, but a consistent amount of them. And when you get very tiny amounts of some metal ion, it can be difficult to keep that concentration consistent because it can either get absorbed into the glass or it's very easy for it to disappear. But in this case, there's a reservoir of it over here, which if some of this gets used up, the equilibrium would shift and make more of it. That's how a metal ion buffer works. But let's talk about pH buffers. A pH buffer is simply the combination of a weak acid and its conjugate base, or a weak base and its conjugate acid. But it is very important that they both be weak. That way, the acid and its conjugate base have acid-base properties. We wouldn't want to use a strong acid or a strong base together because those don't make a buffer. In the end, those ions make a neutral solution that has very little control over what happens to the pH afterwards. So, it's important that we use weak acid and its conjugate base. For a buffer. This buffer will work the best when the pH is very close to the pKa of the weak acid. If you want to know how to calculate pKa, simply take the negative log of the Ka, and that will tell you the pKa. Just like pH, take the negative log of H plus concentration. This buffer will resist change if three things are added to the solution. If I add an acid to the solution, some of the conjugate base will react and use it up, and the pH will move a little bit down, but not a lot, because the conjugate base reacts with it, makes more weak acid, and the pH will move just a little. So, if I were to add an acid to this, only a small change in pH. Similarly, if I add a base to this reaction or system, it will use up some of the weak acid, convert it into the conjugate base, but now all of the strong base will be used up and will be left with only weak acid and conjugate base still. Now, there will be more conjugate base in the solution and the pH will go up a little bit, but not as drastic as if the buffer was not there. Now, there's one more thing that we could do to this solution that wouldn't change the pH, and that is if we diluted it a little bit by adding water. Now, you might think that adding water to a solution will not drastically change its pH. Well, in the case of a buffer, that's true. But if we had a strong acid or a strong base, diluting them will quickly change the pH, especially for lower concentrations of strong acid or strong base. In fact, you can change whole pH units very quickly with a minimal amount of water. With a buffer, that won't happen. So this is just a little bit about what a buffer is and what they do and how you can make one. So again, very important to realize that a buffer has to be a weak acid and its conjugate base if we're talking about a pH buffer. And they must be weak in order for it to work. Strong acids or strong bases alone cannot make a buffer.